Hello, welcome guys. Now we're gonna see the subtopic for the physics for the first chapter is Introduction to Physics. Well, here I'm going to explain to you some of the questions that might be help you during this session. Alright, for the first part is we're gonna look at 6 questions. The first question states physical quantities. Second is about the basic quantity. The third is about derived quantities. The fourth and the fifth is about completing a table that consists of SI unit. And next, number 6, it is about the conservation of unit. Alright, so the first question, state physical quantities. The first thing you have to know is that you have to have an idea how to make an answer, and we have the point that we have learned before that about physical quantity is that can be measured and is about numerical number, and last but not least it should have magnitude, or we can say a unit. So the answer we can put as quantities that can be measured, which consists of precise numerical value and it has magnitude, or we can say it has a unit. Alright, so the next question is about basic quantity, state or definition. But the same thing, you have to know the notes about what's supposed to about relationship between basic quantities. It has length, it cannot be derived, and the answer we can put as quantity that cannot be derived in terms of other physical quantities. So next, let's look at the other question that about derived quantities. So you say states derived quantity. So the points you should know and remember is that derived quantity is combination of basic quantity. The basic quantity, try to remember back. We'll call back what is basic quantity, and it relates to the multiplication or division, or you can say both of it. So the answer we can put as quantity that produced from the combination of basic quantity through multiplication or division or both. You can say any words, but make sure these points are in your answer. Alright, let's take the other slide that is about SI unit. So all these things you have learned before: the length, the mass, the time, the current, the temperature, the amount of substance, and luminosity intensity. Just fill in the table. So SI unit for length, it should be in meter. The mass should be in kilogram, and time will be in second. Electrical, that is the current, should be ampere. The temperature, it should be in Kelvin. It's not Celsius, it's not Fahrenheit. Do keep in mind that it's in Kelvin. And the amount of substance is mole. The luminosity intensity is known as the candela. So next, we can have a little bit of equation to state the SI unit for the quantities. So here we have the velocity, we have the density, we have the frequency, we have the force, we have the pressure, we have the work, and we have the power. So as you can see right now, the velocity is about displacement against time. So displacement is in meter, and the time, because it's under here, it should be -1. Alright, the same thing for the density. The mass should be in kilogram of SI unit, and the volume is meter power of -3. Why it's minus? Because it's below here. Alright, the frequency is in per second. As you can see now, 1 period. And we know frequency, another unit is hertz, but that is not the SI unit. And then we have the force. it is mass, that is times with the acceleration. Acceleration, as you learned before, it is in meter per second square, right? The basic SI unit of the acceleration. And we have the mass here, it should be in kilogram. And then we have the pressure, that is force divided by area. As we look at the force here, the relationship here, it is kilogram meter per second square. We put back inside, and the area should be in meter square. So definitely when we try to what we call that, cut off the SI unit, will have this SI unit that is in kilogram per meter per second square. And then we have the work, that is force times with the displacement. The force, as we have this one again, substitute inside here, we have displacement should be in meter. So lastly, you're going to have this one, the equation that is produced for the SI unit. And then we have the power, last but not least, that is from work over the time. So work, again, this is work units, and then we have the time taken divided by S. So we have S minus 3. So that is for the SI unit. Okay, the next slide, you can look at the conservation of the unit. We have to convert a unit. For the first question is 25 centimeter, convert to meter. So here is quite easy. As you can see now, centimeter should be in power of minus 2. You can change to meter, so we will have the answer is 2.5 times power of minus 1 meter. Now, the second question is 850 milligram. We have to convert to kilogram. So now from small to big. So what we have to do is that change the milli in power of minus 3. And then we add with the kilogram. As we know, kilogram is quite big. So the power of minus 3. So we have now the answer is 850 times power of minus 6 kilogram. There was some question else. We're going to look at question number 3. That is 56 millimeter cube to meter cube. Milli will be in minus 3. Alright, and then we times with the power of 3 to convert to meter. So what we have here is minus 9. So the answer should be, when we put another dot here, we move the one of the dots here, we have 5.6 times power of minus 8 meter cube. And for number 4, we have the kilometer per hour. This is quite interesting. We have to change to meter per second. So kilometer will be in power of minus power of 3. Alright, and then from hours we have to change to second. So from hours to second, 1 hour to second. Second means that 1 minute. So here is supposed to be 60 times the power of 6 times power 30. So something wrong here. It should be 60 times 60. And the answer should be not this one. This is wrong. Okay, we can look at number 5. This is where the Celsius we change to Kelvin, the SI unit. Alright, so from here we say the X here is 75. And then we have the Kelvin changes, that is 273.15. Alright, and times with the X. The X is present as 75. So we have to plus together. What we have is at 348.15 Kelvin. Okay, next we can look at the question that states the similarity between scalar and vector quantity. This is about similarities. That is, the notes we have to know is that the physical, it is a physical quantity, it has numerical value, and it has magnitude. Alright, So these are the symmetry between scalar and vector. Now we're going to look at the difference between it. So as you can see right now, scalar quantity, it has no direction. Compared to vector quantity, it has direction. So for both of these symmetries, we should state the example. Now for scalar quantities, the example we can put is that 10 meter distance, 2 kilogram mass. This is without direction. Okay, meanwhile for the vector, we can state the units now, 1 kilometer, and also the direction, whether it is stated to the east or to the right. This show the direction. The same thing for 5 Newton with units, and upward means that it is going up, a direction is showing. And another one we can put is that 200 Newton force with an angle of 30 degrees north of west. So this showing the direction for the quantities. So the next slide we're going to look at is the V, E, C, T, O, R. Vector. So it is quite simple as long as you follow the rules that we put for it. Alright, I've placed 2 questions for the vector. So this is the first question, the basic things that you should know. Now, given now a displacement vector has a magnitude of r equals to 175 meter. So given now the units of the vector for r and point of angle of 50 degrees relative to the x-axis. So now it's given now the x-axis it has 50 degrees, and find the x and y component of this vector. So it means that we have to find the value of x, the value of y, that sum to have the r. Alright, the first thing being given is that the magnitude of the r, that is 175 meter. So please bet the value 175 or write back the 175 meter at r. So it's quite easy, we have to have a complete diagram. The next step you have to do is that build a table that consists of x and y components. So this is how it looks for the table. It's up to you to do it, but we have to remember that you're supposed to have x and y to show that how they are being produced. Okay, now we look first at the x-axis or the x component. But the first thing we have to do is that we have to draw this part to show a triangle being built. And then we can look at the y that is going up, and then we have the x is going to the right side, okay, going to the right side, right? And then this is where we put the rx or the x component for r. And you can see right now the arrow is showing towards to here, showing is that any angle that facing this part will be sine. It's always sine, and beside it or opposite of it will be cos. That's why we have rx is equals to r cos theta, because the sine is related to the y component, and for the x it should be cos. Alright, so angle is 50 degrees. 175 represents the value of the magnitude of r. So we have the x component is 112 meters, and it is positive because it is to the right side. Okay, now the value of our x after we calculate will be 112 meter. Now we can look at the y component. For the y component, as you can see, the arrow of the red is showing is that it is going upwards. Either you can put here or here you can take, but let's take it here, easier. And we know now it should be in sign. So for the y component, sign going upwards will be positive, and put back the value of r at 175 with the angle of 50 degrees. We're gonna have the y component 134 meter. So we can conclude now that for the questions, the x and y component combination produce the magnitude of r. Next, we're going to look at the second question and pay attention to the question and how to solve it. Alright, for this question, as you can see right now, it has 4 vectors. There are 4 vectors of different value. The magnitude showing here, and we have to find it a new vector for it. Means that the combination of all the vectors A, B, C, and D. The first thing we have to do is that make sure we substitute all the value that is for the vector. Alright, once we've done this, means that we have a complete vector, as we know the value of each magnitude. Again, we have to build a table of x and y. So firstly, we'll go to the first vector, that is A. We have to find the x and y component. Compared to the previous question, we find the x and y. Correct? Where we have the resultant of A. The same thing right now, we have to find the x and y component of each of the vector from A to D. The first thing we have to do is that draw a triangle. Alright, that consists of angle of 20 degrees and a magnitude of 16 meter. The x component here and also the y component is another way. As we can see right now, the x components is to the left side. If you build triangle and look at the arrow here of the magnitude of A, shows that it's going this way to the left. And the y component, alright, so the y component is going upwards. You have a complete triangle to solve the vector of A. So the x value is to the left. When to the left means that we have the negative here, alright, and the y component is going up. It's supposed to be positive. Substitute all the value that we have exactly just like the first or the previous question of vector. Then you will have the x component is minus 15 meter. Meanwhile, for the y component will be positive 5.47 meter. Now, we can look at the other vector, that is B. For the vector B, it just stands alone at the y. That's why the x is 0, because the vector is going straight upwards and it doesn't have any angle, and that's why the y component for the B vector will be 11, and because it's going upwards, it should be positive. Now we can look at the other component, that is the C. Again, for C, what we have to do is that we have to complete a triangle. Once we have the triangle here that consists of 35 degrees angle, we can find the value of C at the X component and Y at the X component. As you can see right now, the CX, or the component of X of C, is going to the left. And again, we have the minus C. To the left will be minus, and we have minus 9.83 meter. And for the Y component, should going downwards, in other words. Alright, so with going down means that it should be negative. So put the negative at the Y component, and we have negative 6.88 meter. That completes for the C. And we're going to wrap up at D component for the vector. Again, you have to complete as a triangle with the angle of 50 degrees, and then we're going to find the D component at X, which is going to the right side. And the value of the X is supposed to be positive, and we're going to have it 16.7 meter. And last but not least, the Y component is going downwards, so it should be negative 19.9 meter. Take note about the direction and learn how to build a triangle. So now we can find the value of all of the components, that is from the X and Y, and we substitute back into a table that consists all the 4 vectors, and then we can have the value of the X component, or the new magnitude, or the new vector, that is minus 813 meter. This is the sum for each of the vectors starting from A to D. And then we have the Y component, alright, for all the component of Y, that is minus 10.3 meter. And class, the solution here doesn't stop. We have to find the magnitude. So the magnitude, it has the equation that you have learned before, where the X plus with the Y, and we will have 13.1 meter. And we have the direction, that is last but not least, these are the answer will be 51.7 degrees, where the Y component divided by the X component. If let's say now it has the value of negative, just put the negative back. If it's positive, just put positive. It's quite simple, class. Just follow the rules, everything, and that's wrap up for everything that we have learned for the first chapter. Thank you very much for your time, and see you again. Okay, bye bye. Thank you.